We're being asked the absolute value of x is less than or equal to 2. There can be two different answers because if I had a positive 2 in here, then the positive 2's absolute value would be 2, and 2 is less than or equal to 2. And then I can also put a minus 2 in here, and the absolute value of minus 2 is less than or equal to 2 because the absolute value of minus 2 is 2. And the way that we solve this is we set x equal to positive 2 and x equal to negative 2. Well, what we just did will allow us to solve this one now. I want to find x values that when they're inside the absolute value symbol here, then I have some number plus 5 is greater than or equal to 8. And the way that I solve this is I take what's inside the inequality, x plus 5, and I set it equal to positive 8 and negative 8. And for both of these two equations, I want to subtract 5 from both sides. Once we do that, we get two values, x equals 3 and x equals minus 13. What I'm going to do is I'm going to plug in the x equals 3 into the original inequality. And what I get is 3 plus 5 inside the absolute value symbol. So I have absolute value of 8, which is 8, is greater than or equal to 8. So the 3 works. And the same thing with the minus 13, plugging it into the original inequality, we get absolute value of minus 13 plus 5 is going to be minus 8, and the absolute value of minus 8 is 8, and 8 is greater than or equal to 8, so that's true. So now, looking at a graph of this, we have as our boundaries minus 13 and 3, and since these values are when it equals, these will be closed dots. When we're doing the graph here, we need to determine, are the points in between minus 13 and 3 part of our graph, or is it the points that are outside the boundaries, in other words, greater than 3 or less than 13? And the way that we do this is first we test with a number that's in between. Well, 0 is in between, so if I put 0 in here, I have 0 plus 5 is greater than or equal to 8, and that's not true, so it's not going to be in here. So now this is inside here, we would say that that's false. So for in here, those values are false. So they're not going to include these two. And it changes how we write the inequality. Now I want to test values that are going to be greater than 3. So if I go over here and I put a 4, I have 4 plus 5 is the absolute value of 9, and 9 is greater than. So we can then shade this part, and I need to test a number that is smaller than minus 13. So if I do a value of minus 15, which would be to the left of minus 13, minus 15 plus 10 is minus 10, and the absolute value of minus 10 is 10. 10 is greater than or equal to 8, so this graph would go this way. So now when we write this, it changes. It's not always this inequality that gets used, so what I want to do is I want to write, these are going to be x values that are less than or equal to minus 13. And for over here, it's going to be x values that are greater than or equal to 3. And in order to link these two together, I want to put the word or in between, or you can use the union symbol. Here we're being asked to find the absolute value of x minus 10 is less than or equal to 2. And this time you'll notice that this is less than or equal to. And this usually is an indicator that the inequality can be written as a compound inequality. So the first thing that I want to do is write what's inside the inequality as two separate equations that sets the x minus 10 equal to positive and negative 2. Are two outcomes for absolute value. And in both cases here, I'm going to add 10 to both sides. So what I find is that I get two values, x equals 12 and x equals 8. And when I plug the 12 in, I get absolute value of 2 is less than or equal to 2, and it's positive 2 or negative 2 inside is still going to make it 2 is less than or equal to 2. So if I put 8 inside, what I get is minus 2, and the absolute value of minus 2 is 2, and 2 again is less than or equal to 2. So now graphing this, I see that this is equals, so I can have closed dots for both 8 and 12. And again, I need to test to see if they're going to be values in between that satisfy, and that's true, or if the values are to the outside, as in the last problem. So let's try 9. So I have 9 minus 10 is minus 1, and the absolute value of minus 1 is 1. 1 is less than or equal to 2. So it's true. And inside here, this is going to be shaded this way. So when they're linked together like this, I can write the inequality with the boundaries of 8 and 12. X has to be in between those values. So it'd be 8 is less than or equal to X, which is less than or equal to 12. And this is our final answer. In this next example, we see that we have things that are outside the absolute value. So in order to do this, we have to first get the absolute value of X plus 7 by itself. I start that by first subtracting 8 from both sides, which leaves us with 2 times the absolute value of X plus 7 is greater than 4. So the next thing I'll do is divide both sides by 2. And now our absolute value inequality is in the correct form for us to solve it. So I'm going to set X plus 7 equal to positive 2 and negative 2. And then I'll solve both one-step equations by subtracting 7 from both sides. So now I'm going to get X equals minus 5 and minus 9, so I'm going to graph that. So I know from our original absolute value of inequality, we had just greater than, it didn't have the equal, so I know that the minus 9 and the minus 5 are going to be open dots. And now I have to test to see if we have a compound inequality or if I have to use two inequalities connected with an or. So I want to test in between here, so I'm going to test minus 6. And when I put a minus 6 in here, I'm going to get a positive 1. Absolute value of positive 1 is 1, and 1 is not greater than 2, so it fails inside here. So then I'm going to try 0 to see if it's to the right. So when I put a 0 in here, I get the absolute value of 7 is greater than 2, and that's true. So this here goes this way on the graph. And then I'm going to try minus 10. So minus 10 plus 7 is minus 3, and the absolute value of minus 3 is 3. 3 is greater than 2, so this also passes when I go to the side over here. So these here are going to be connected with an or. So I'm going to put X is less than minus 9, or X is greater than minus 5. In this example, we again have values that are outside the absolute value symbol, but what's inside here is a two-step equation. It's not really that much more difficult, but just a little bit of housekeeping. So I start by adding 5 to both sides. And then I divide both sides by minus 3. And now that the only thing on the left is the absolute value of 8 plus 2x, I'm going to set that equal to positive and negative 4. In order to solve the two-step equation, first I'll subtract 8 from both sides of both of these equations. And then I divide both sides by 2. This gives me x equals minus 2 and x equals minus 6. I then graph them. Now, in the original inequality, it didn't have the equal sign, so these are going to be open dots. And as you may recall, we have to test to see if a value in between works. That would make it a compound inequality. If the values outside work, then it would be an or inequality. So we'll test with minus 4. Coming back to here, I have 8 plus 2 times minus 4 is minus 8, so 8 plus minus 8 is 0, and the absolute value of 0 is 0. 0 is less than 4, so the values in between here are going to work, so I'm going to shade in that passes. So I can write this inequality as minus 6 is less than x, which is less than minus 2, and that's our final answer.